Welcome back to week 5, and in video 4 we are going to discuss the driving forces between or behind atmospheric circulation. So basically the major driving forces are air temperature and density, which is directly related to the amount of solar radiation that reaches the Earth. This produces high and low pressure centers. Also the Coriolis effect, or the rotation of the Earth. We'll talk about the Coriolis effect in the next few slides here. And then we're going to talk and use the GeoAtlas program, which you have linked in the course website. And basically the reason why we know about atmospheric circulation patterns is partially due to measuring and collecting data from different parts of the globe, but also by taking that data and applying models using that data. So these can help us determine how winds drive currents, how the Earth's rotation affects those winds. And then we're going to get through the next few slides, kind of step-by-step intro to controlling atmospheric currents. And then make sure you watch the video about the Coriolis effect that is posted on the course website as well. So, if we start with the basics, we have a sphere, the Earth. It's not rotating. We have simple circulation, one circulation cell instead of the 3 that we can think of today. We start out air rising at the equator, sinking at the pole. So if we have the Earth totally still, not rotating, we're going to have just this basic up and down pattern around the globe. So if we start spinning the Earth, these patterns are going to be diverted. So the airflow is going to be diverted in the northern hemisphere to the right, and in the southern hemisphere to the left. So because of this diversion due to the Earth rotating, this is the Coriolis effect, you should watch that video, we end up producing the trade winds that can develop on the surface of the Earth. So if we think back to this image here showing those 3 circulation patterns, you see how the trade winds are actually diverted in the northern hemisphere to the right. Here you can see it's diverted to the right, and that is because of the Coriolis effect. So make sure you visit that website and video on YouTube. So what I also wanted to talk about with these driving forces, if you visit the course homepage and you click on this additional resources and website link, you will see these helpful websites. If you scroll down, you'll see GeoAtlas. You'll have to enter username and password that's listed in the course site. We're going to go to the map. And here you can see a satellite image showing you the Earth. And here we got the equator. You can see we have some storm systems that develop. Here we have our neck of the woods, lots of low pressure zones that had developed. And that's because we have air rising at the equator, cooling, condensing, and sinking. And then here we have air rising at in the subtropical jet, producing those lows and those spiral patterns that you see. So I wanted to show you kind of compare temperature and air pressure. So if I click on the summer air temperature, we can see that along the equator, higher temperature. Makes sense. Lots of incoming solar radiation. If I click on insolation to see what things are like as far as how much energy is reaching the surface, we can see, yes, lots of energy about at the equator. So, and that is during the summer. If we look at the surface air pressure, we can see that we have lows that develop along the equator where we have that air rising, and then we have high pressure where the air is sinking as well. And then if you look at the upper air currents, upper air pressure, we see that things have this kind of parallel pattern. So surface air pressure, we got the high pressure zones where it's sinking, low pressure where it is rising. And so if I were to switch this to wintertime, we should see a shift in where those highs and lows are. And we do. We see our low pressure centers end up being much more developed in our neck of the woods. It's because in the wintertime we have more storms rolling across the country. Our high pressure zones are smaller, and we have everything kind of shifting to the south as a result of the seasons and the Earth's tilt changing in its relationship to the sun. So make sure you check out the video that is linked. If I scroll down to week 5, air pressure and winds, week 5 videos, you will see this bottom video, Coriolis force tutorial from grad students at the University of Illinois. So make sure you watch that. It is very helpful to understanding what the Coriolis force is and how it relates to both the atmosphere and the oceans. So that wraps up driving forces. We'll come back and talk about measuring air pressure and winds in the last video.